Hey guys, we have been learning many concepts and corresponding questions from soil mechanics and foundation engineering. You can check it out all the concepts and the corresponding questions, important questions in this geotechnical engineering playlist in which we have added all the things that we are already dealing with. And now we shall move on to earth pressure theories. In the continuation to that series, now we shall move on to earth pressure theories and retaining wall and what are the important concepts, what are the important formulas that we can expect in an examination. Now let's start with the first question. The first question is earth pressure and resultant possibility of wall movement are shown below. This is the representative diagram in which they have mentioned the earth pressure and the resultant possibility of wall movement. So wall movement is this one away from the backfill and towards backfill. The earth pressure points x, y and z are. So this x and y and z points represents which type of earth pressure. Correspondingly, we have to answer the option. Which option is correct regarding x and y and z? So here the option is option D, passive, rest and active. That is, the x point represents passive earth pressure, y point represents at rest earth pressure, and z represents active earth pressure. Now we shall see more about what is active, what is at rest earth pressure and passive earth pressure. Active earth pressure is always minimum. As you can see in this representation, Z is here. So the pressure is minimum and X is higher. So that means the earth pressure is maximum in case of passive condition. And it will be in a medium range at rest earth pressure. So at rest earth pressure will be existing in abutments, basement walls. What that means is there will be no relative movement between wall and soil. There will be no relative movement between wall and soil, and hence there will be no yielding of soil mass. For example, you can see this is one abutment wall, and similarly here also there is one abutment wall. So in between that we can expect a backfill or the soil fill, and the movement between this and this will be zero. So there will be no relative movement. That means the pressure is called as at rest earth pressure. The condition is elastic equilibrium condition will be existing, and the wall earth system is considered to be rigid because there is no yielding. So that's why the wall earth system is considered to be rigid. And next is the ordinary retaining walls. This will be under active earth pressure. So active earth pressure means the wall is moving away from backfill. So that is called as active earth pressure. So wall moves away from soil and the soils yield by stretching. So soil is stretching by yielding. The soil is yielding by stretching, and the lateral earth pressure shall be greater than self weight of the wall. When this condition is existing, we can say the earth pressure is active in condition, that is active earth pressure is existing when lateral earth pressure is greater than self weight of the wall, and the condition is plastic equilibrium condition at the verge of failure. So at rest earth pressure we can expect an elastic equilibrium condition, and for active earth pressure the plastic equilibrium condition will be existing at the verge of failure, and the opposite of its kind is the passive earth pressure. The wall is moving towards the soil is the passive earth pressure, you can see in this representation. So the wall is moving towards the backfill. That means the condition is passive earth pressure, and the plastic equilibrium condition will also be existing here at the verge of failure, and we shall see more about passive and active earth pressure in the upcoming questions and the formula regarding that. Now let's move on to the next question. This question deals with the at rest earth pressure. The coefficient of the earth pressure at rest in terms of Poisson's ratio is option A nu by 1 minus nu, option B nu by 1 plus nu, option C nu by 1 plus nu square, option D minus nu by 1 minus nu. So what is the coefficient of at rest earth pressure in terms of Poisson's ratio? Now let's see the answer. Option A nu by 1 minus nu is the coefficient of at rest earth pressure with respect to Poisson's ratio, and we shall see what actually is the lateral earth pressure. So lateral earth pressure in general it is denoted by small k, and that is nothing but ratio of horizontal stress to the vertical stress, and the stress should be in effective. That is effective stress has to be, so effective value has to be taken. K is equal to horizontal stress divided by vertical stress. And what is lateral stress? That is nothing but sigma h. Sigma h is the lateral stress. So that means sigma h value will be nothing but K into vertical stress. So vertical stress, we know how to find that, and K is the coefficient of at rest earth pressure or active earth pressure or passive earth pressure correspondingly in the given situation. If it is at rest earth pressure, then K naught shall be equal to nu by 1 minus nu in terms of Poisson's ratio, or 1 minus sine phi. So this is the at rest earth pressure coefficient in terms of Poisson's ratio and in terms of angle of internal friction of soil, that is phi. So K naught is equal to 1 minus sine phi. This is the at rest earth pressure coefficient. And moving on to active earth pressure coefficient, that is denoted by K suffix A, that is nothing but K is equal to 1 minus sine phi by 1 plus sine phi. So this is the coefficient of active earth pressure, 1 minus sine phi by 1 plus sine phi, where phi is nothing but angle of internal friction. It can also be denoted by tan square 45 minus pi by 2, or we can call it as cot square 45 plus pi by 2. So this is the coefficient of active earth pressure. Next, move on to passive earth pressure coefficient. That is nothing but K suffix P. That is the reciprocal of active earth pressure coefficient. That is 1 plus sine phi by 1 minus sine phi, or we can say tan square 45 plus pi by 2. So this is the passive earth pressure coefficient. That means the active earth pressure coefficient and passive earth pressure coefficient are reciprocal to each other. So that's why product of active and passive earth pressure coefficients are always 1. So these are applicable when the backfill is straight. Backfill is horizontal. When the backfill is inclined like this, so here you can see in this diagram, here the inclination angle is beta with respect to horizontal. Then what will be the coefficient of active and passive earth pressure? Here you can see K is equal to cos beta into cos beta minus root of cos square beta minus cos square phi. So this term is as such, and this in the denominator also. Just interchange the sign. So in the numerator cos beta minus root of cos square beta minus cos square phi. Below the same thing, same parameter, but sign only is changed. So this is how we have to calculate the um, coefficient of earth pressure when the backfill is inclined. Similarly, in case of Kp, that is in case of passive earth pressure coefficient, then cos beta is equal to cos beta plus. In the numerator, we have to insert the plus symbol, root of cos square beta minus cos square phi divided by cos beta minus cos root of cos square beta minus cos square phi. So we have already seen like K and Kp are reciprocal to each other. So that's why the formula is like this. So we have seen all the coefficients, like in general K is equal to sigma h by sigma v, and in case of at rest earth pressure, K naught is equal to nu by 1 minus nu or 1 minus sine phi. In case of active, K is equal to 1 minus sine phi by 1 plus sine phi. In case of passive, Kp is equal to 1 plus sine phi by 1 minus sine phi, and the product of the both should always be 1. And in case of inclined backfill, formula goes like this. Now moving on to the third question. A retaining wall 8-meter high with a smooth vertical back retains a clay backfill with effective cohesion value 15 kN per meter square, and the angle of internal friction value is given as 15 degree, and the unit weight of soil or the unit weight of clay backfill is 18 kN per meter square. We have to calculate the magnitude of active earth pressure at the top. So at the topmost position of the backfill, what will be the magnitude of active earth pressure, that we have to find. Let's see how to calculate that. Option B is correct one, 23.02 kilonewton per meter square. So the active earth pressure is given by using this relation or this formula. Ka into gamma z minus 2c root Ka. That is nothing but Ka into the vertical effective stress, that is gamma into z. Since there is no water table present or there is no mention of water table, we can use the given unit weight as such. So that's why Ka into gamma into z minus 2c root Ka. Why this minus 2c root Ka? Because the backfill is clay, backfill is cohesive soil. So that is why we have to insert, or we have to include this term minus 2c root Ka. So this is a general formula at any depth, and we have to calculate at the depth of 0th meter, that is at the top. So that means at z is equal to 0, what is the Pa? Before that, we have to find Ka value. Here active earth pressure, since active earth pressure, we can use 1 minus sine phi by 1 plus sine phi. Phi here is 15 degree. On substituting there, we can get Ka as 0.589. And at z is equal to 0, that is at the top of the backfill, what is the pressure value? Pa is equal to uh, z is equal to 0, that means this term will get vanished off, and minus 2 into c, what is c here? 15 root of Ka is 0.589. So minus 2 into 15 into root of 0.589 gives answer as minus 23.02 kilonewton per meter square. So option B is correct. Now we shall see some more points regarding this. So first formula we have seen this one, the active earth pressure at any depth, and now we shall see the next formula regarding depth of tension crack. This will happen when there is a clay backfill. So due to cohesion value, there will be a tension crack formation. So here in this diagram you can see. So this is the negative earth pressure occurring due to the cohesion value, and up to certain depth there is the zero earth pressure. So that depth is known as tension crack depth. And twice the tough tension crack is nothing but HC, that is critical depth, or we can say unsupported vertical height or cut. So first ZC is nothing but 2C by gamma root Ka. So this is the formula for depth of tension crack, 2C by gamma root Ka. Gamma is the unit weight of soil. Ka we know 1 minus sine phi by 1 plus sine phi. C is the cohesion value. And twice the depth of tension crack is nothing but unsupported vertical height or cut. That means that without retaining wall over HC, the soil can withstand by its own cohesion. So that is nothing but HC is equal to 4C by gamma root K. That is the unsupported vertical height or cut. These are the important things regarding active earth pressure in case of clay backfill. And this is the formula when there existing passive earth pressure. So in case of passive earth pressure, Kp gamma is at plus 2C root Kp. So that means there is no tension crack formation in case of passive earth pressure because the wall is moving towards the backfill. So towards the backfill, then there will be no condition of tension crack. And the Kp gamma is at plus 2C root Kp is the passive earth pressure at any depth. We can find like this. So for example, this is the retaining wall, and this is how the earth pressure will be varying. There is no zero or zeroth or the tension crack depth in case of passive condition, and this is in case of active condition. This is the tension crack depth, and this is the depth of unsupported vertical height or cut, we can say, due to the cohesion present in the backfill, that is nothing but clay. So here we have learned about earth pressure at any depth in case of clay backfill, and the depth of tension crack, and the unsupported vertical height or cut, and what the pressure will be in case of passive condition. Now we shall move on to the next question. A retaining wall with stratified backfill and a surcharge load is given. Here you can see this 20 kN per meter square is the surcharge load above the backfill, and the backfill has two stratification. In the first layer, we can see some parameters like gamma, that is unit weight of the first stratification is 16 kN per meter cube, and angle of internal friction is given as 30°, and there is no cohesion. But in the second layer, we can see cohesion value 15 kilopascal. That means in the second layer there is some presence of clay matter, and the unit weight of the soil is given as 18 kilonewton per meter cube, and the angle of internal friction is 15°. And there is no mention about the water table, so the unit weight of the soil as such we can take into calculation. Here we have to find the passive earth pressure point A. We have to find the passive earth pressure at point A, that is at the bottom of the backfill, at the base of the backfill, we can say like that. So here the option is option C, 303.980 kilonewton per meter square. Let's see the calculation part. So first let's calculate the coefficient value. Here they have mentioned passive earth pressure is occurring. So that's why we are calculating passive earth pressure coefficient at the first layer and at the second layer according to the angle of internal friction value. So what is Kp? Kp is nothing but 1 plus sin phi by 1 minus sin phi. So substitute phi value as 30° in this formula and phi value 15° in this second layer, so that we can get answers like this. Kp1 is equal to 3 and Kp2 is equal to 1.698. And from the first layer or the zeroth depth we can find the pressure value. So pressure is given as Kp1 into Q. How? Because there is one surcharge occurring at the top of the soil. So first considering the surcharge, we can get the value for P1 as Kp1 into Q, that is 3 into 20, that is 60 kilonewton per meter square. For example, let's draw the diagram. So this is 60 at the top of the layer, and at 4 meter, that is at the middle of the layer, just above the middle of the layer and just below the middle of the layer we have to consider, because there is a stratification occurring. So at z is equal to 4 meter and just above that layer, that is top layer, what is the pressure? So P2 is equal to Kp1 into Q plus gamma 1 into Z1. This Q we have to consider because there is a uniform surcharge occurring over the top of the soil. So that's why we are considering Q, and P2 is equal to Kp1 into why Kp1, because we are considering top layer. So that's why Kp of the first layer is used. P2 is equal to Kp1 into Q plus gamma 1 into Z1. So 3 into 20 plus 16 into 4 will give answer as 252. So here you can see this is the 0th depth and this is the 4th meter, and let this point be 252, or say this point is 252. Okay, so this is 252, and just below that layer, just below the 4 meter layer, second stratification is occurring. So that's why we are considering Kp2 value here. So P3 is equal to, or the third pressure value is equal to Kp2 into Q plus gamma 1 Z1, because the above the top layer or the above the 4 meter, we have to consider gamma 1 Z1 only. We should not consider mistakenly as gamma 2 Z2. Just below the just below the 4 meter layer, 4 meter depth, what is the stress due to the second soil? That's why we are considering Kp2 value here. Kp2 into Q plus gamma 1 Z1 plus 2C root Kp2. This we have to consider because in this first layer the cohesion is 0. So that's why there is no job to insert 2C root K value. But here the cohesion is occurring. So C equal to 15 kilopascal. So that's why we have to add plus 2C root Kp. Why we are adding, or why we are plus why we are adding plus sign here? Because the earth pressure is passive. In case of active earth pressure, we have to negate, like minus 2C root Ka. In case of passive condition, we have to add plus 2Z root Ka. Plus 2Z root Kp. So here you can see Kp2 into Q plus gamma 1 Z1 plus 2C root Kp2. So on substituting all the values over here, we can get like this 181.72. So consider this point as 181.72. Okay, this point as 181.72 at just below the 4 meter layer, and at the bottom layer, that is z is equal to 8 meter, what will be the value? Actually this only has to be found out, but yet we can get to know how to find all the pressure values at different depths. So at z is equal to 8 meter, that is at the bottommost point, what is the pressure value? So P4 is equal to Kp2. Why Kp2? Because we are considering the second layer. Because that point is in the second layer. Kp2 into Q plus gamma 1 Z1 plus gamma 2 Z2. Whatever the surcharge or the load or the soil above that layer, we have to consider. One is surcharge, uniform surcharge, one is first layer backfill, next layer backfill, and plus 2c root kp2 because of passive condition. So upon substituting all the things, we can get 303.98 as the answer. So this is the pressure varying diagram. So this is the first layer and this is the second layer, and this is the active earth pressure varying diagram. Sorry, passive earth pressure varying diagram in case of this question. In this question, they have clearly mentioned passive earth pressure. So accordingly, we have calculated. In case of active earth pressure, we have to use Ka values. Simply change all the formulas into Ka and find the answer. And in case of active earth pressure, this plus sign has to be closely monitored to change it to minus sign. Here in case of passive earth pressure, plus 2c root kp. So this is a big problem and yet important problem regarding passive earth pressure calculation. Now let's move on to fifth question. The given figure shows Culmann's graphical construction of earth pressure. So this is a Culmann's graphical construction of earth pressure, and is the angle of wall friction. The earth pressure line is represented by which line? Whether it is AB or AD or BD or BC. So which line represents the earth pressure line? That we shall see now. Here the answer is option D, BC. This is an important theory of earth pressure. So the earth pressure line represents the active pressure due to the weight of trial wedges formed by assumed failure surface. So say this is an assumed failure surface, and this BC is the line which is representing earth pressure, and that is due to active pressure. The failure surfaces originate from point B. So here this is the point B, and from this point the failure surfaces origin, and the weight of trial wedge are marked on BD line. This is the wedge and weight of which is marked on BD line, and the BD line is nothing but the phi line. Here you can see the mentioning of phi, that is the angle of internal friction. In this diagram also you can clearly see this BL is the earth pressure line, BD is called as phi line, and this line, or this is the points joining this line, is called as Culmann's line. That is the Culmann's line, and here you can see the failure plane, tangent to which is the failure plane. This is one theory regarding earth pressure. We have many more theories like Rankine's, Coulomb's wedge theory, and here Ramon's theory, and now we have seen Culmann's graphical construction. We shall move on to the next question now. Which of the following statements are correct regarding Coulomb's earth pressure theory? So in the previous question we have seen Culmann's earth pressure theory. In this question we are going to see Coulomb's earth pressure theory. So option A, that is based, it is based on wedge theory, whether it is correct or not, that we have to follow that. So option B is given as assume the Coulomb's earth pressure theory assumes the wall surface rough, and option C and option D accordingly. So which of the following statements are correct regarding Coulomb's earth pressure theory? So option A and B, that is the Coulomb's earth pressure theory is based on wedge theory. That means the a wedge of soil is considered and the failure pattern is analyzed. So that is the that is called as the wedge theory, and it assumes the wall surface rough. The wall surface is rough in case of Coulomb's earth pressure theory, but it will be different in case of Rankine's. In Rankine's earth pressure theory, the wall surface is considered to be smooth. So here it is considered to be rough. Now we shall see other assumptions. Firstly, the soil is homogeneous, isotropic, semi-infinite, dry, elastic, and cohesionless soil. That is, we have to consider only the sandy or gravelly soil. There should not be cohesion in that. So that's why cohesionless soil is assumed. And the face of wall and that is contact with the backfill, that is, this is the face of the wall which is in contact with backfill, is vertical or inclined and should be rough. This this face of the wall, it can be vertical or inclined, and it should be rough. It is assumed to be rough. So that's why there exists angle of friction between wall and backfill, that is denoted by del. And in case of smooth wall, the del value, that is angle of friction between wall and backfill, is given by 5 by 3. In case of ordinary retaining wall, 2 5 by 3. In case of very rough walls, it will be 3 5 by 4. And move on to next assumption. Failure wedge acts as a rigid body. This is a failure wedge. This acts as a rigid body. That is, there will be no yielding, and the stresses acting over it are uniform. The stress acting over it are assumed to be uniform. The failure is two-dimensional. The failure surface will be planar and passes through the wall heel. So this is the wall heel, and the failure is passing through this point, and this failure surface is assumed as planar, and that will be two-dimensional. The point of application and line of action of resultant thrust between the wall and the soil is unknown. There it is, sorry, it is known actually. Point of application and line of action of resultant thrust between wall and soil is known. So that is a major assumption, and this theory is not suitable for passive state condition since the failure surface is assumed as planar. But in actual case, the failure surface will be circular in case of passive state condition. Only in case of active state condition, the failure surface which is assumed as planar can be suitable. But in case of passive state condition, in reality, the failure surface will be circular. But in Coulomb's wedge theory, we have considered, or we have in Coulomb's wedge theory, it is assumed to be planar only, and it does not satisfy the static equilibrium. Coulomb's wedge theory does not satisfy the static equilibrium condition that is occurring in nature. So these two are some demerits regarding Coulomb's earth pressure theory. And similarly, we can follow assumptions in Rankine's earth pressure theory. In Rankine's theory, we are considering elemental failure. Here we are considering wedge failure, right? In Coulomb's theory, we are considering wedge failure, but in Rankine's theory, we are considering elemental failure. That is one a difference between Rankine's and Coulomb's theory. And another thing is, wall is assumed to be smooth in case of Rankine's theory, and wall is assumed to be rough in case of Coulomb's wedge theory. And other assumptions in Rankine's theory, like soil is homogeneous, isotropic, cohesionless, will also be applicable to Rankine's theory also. And the backfill surface at the top is horizontal in case of Rankine's theory. There should not be inclined surface. As like in this Coulomb's theory, we can see the wedge surface can be inclined. But in case of Rankine's earth pressure theory, the backfill surface at the top should be horizontal. There should not be inclination of the backfill. That is, there should not be beta value. Beta should be 0. And the face of the wall which is in contact with the backfill is vertical only. There should not be any inclination of the wall, and it should be smooth. And the soil is in a state of plastic equilibrium during both active and passive earth pressure conditions in case of Rankine's earth pressure theory. And the rupture surface is planar again, and that can be determined by considering the equilibrium under different forces. So the planar condition is also applicable to Rankine's theory, and Rankine's theory can be applicable to cohesive soils also. Not only in cohesionless soil, Rankine's theory can also be applicable to cohesive soil also. But in case of Coulomb's earth pressure theory, we cannot apply this theory to cohesive soils. So these are some similarities and differences between Coulomb's earth pressure theory and Rankine's earth pressure theory. Now we shall move on to the next question. Find the resultant thrust and its position from bottom from the base of the backfill. For the problem number 4. In the fourth question, we have already seen the calculation part and found the answer for the passive pressure values at various depth, like at 0th meter or the top layer, what is the passive pressure, and at 4th layer, how the pressure is varying, and at the bottom of the backfill, the passive pressure will be 304 kilonewton per meter square. The same data has to be followed here to determine the resultant thrust and where it is acting from the bottom or the base of the backfill, that we have to find. So that is denoted by PP, and the position of it, which is measured from the bottom, is denoted as small h. Here the options are A, B, and correct. PP is equal to 1596 kilonewton per meter run, and it is acting at 3.3 meter from the base. Now let's see the calculation part, how it will be found. Like first we shall consider the first strata, and next we shall move on to the next strata. So first we shall consider the strata 1. In this, we have to find the area of this trapezium block. This block is actually trapezium. The area of it is it should be calculated. That is nothing but the average between the average of two width. Like here 60 and here is 252. So 60 plus 252 divided by 2 into the height of the layer. Height of the layer is 4. So 4 into 60 plus 252 by 2 gives 624 kilonewton per meter run as the answer for the thrust which is acting in the first layer alone. Similarly, we can move on to second layer. PP2 is equal to 4 into 182 plus 304 by 2. That is nothing but 972 kilonewton per meter. Here you can see in this diagram. So here second trapezium, that is 182 and 304 are the width of trapezium, and average of it into the height of the trapezium. Here the height of the trapezium is 4 meter. So 4 into 182 plus 304 by 2 gives 972 kilonewton per meter. And upon adding both the things, we can get the total thrust value, that is PP, as 1596 kilonewton per meter. This is how we have to calculate. A simple calculation, which is nothing but we have to calculate the area of the earth pressure diagram or the earth pressure block, and find the answer for total thrust by summing up all the things, summing up the pressure or the thrust for all the layers. Here we have two layers, so that's why PP1 plus PP2. And we shall see the calculation part for the position of it. Like first we shall calculate the position of PP1 from the base of the first layer, that is noted as Y1. So Y1, how to calculate that? So this is nothing but the centroidal distance of the given shape. Here the shape is given the shape we have found is the trapezium. For the trapezium, what is the centroidal distance? So 2 into top width plus 252. 2 into top width plus bottom width, that is 252, divided by summation of the both the widths, that is 60 plus 252 into 4 by 3. This is a kind of formula that we can follow to find the centroidal distance from the base of the trapezium. So y1 is 2 into 60 plus 252 divided by 60 plus 252, this whole bracket into 4 by 3. That gives us 1.58 meter as the answer for y1 value. This is the y1, that is nothing from the bottom of the strata 1 to somewhere. So that is the y1 value. And similarly, we can find the y2 value, that is centroidal distance of the second layer from the bottom of that layer. That is nothing but 2 into the top width. Here the top width is 182. So 2 into 182 plus 304, that is bottom width, divided by summation, that is 182 plus 304 into 4 by 3. So 1.83 meter is the central distance of the second trapezium or the second earth pressure variation. So upon taking moment about the bottom, so about the bottom we can take the moment so that we can calculate the h value. So pp into h is equal to pp1 into 4 plus y1. Why 4 plus y1? Because about the bottom we are calculating. So this layer wholly we have to consider 4 plus y1, that is this distance. This is the thing at which BP1 is acting. So that's why 4 plus y1 distance plus pp2 into y2. Here you can see this is the y2 value at which pp2 is acting. So pp2 plus y2. So upon taking moment at bottom, we know pp value and all other things, pp1, y1, pp2 and y2. So upon substituting values here, we can get the answer for H, that is the location at which the resultant thrust is acting from the bottom. That is nothing but 3.3 meter in this case. So this is the approach to find the total resultant thrust value and its position. Uh, this will be similar in case of active earth pressure also. The same approach has to be followed in case of active earth pressure. The only thing is there will be a difference in pressure distribution diagram, and because we are considering Ka value, that is coefficient of active earth pressure value. So this is an important thing that we have to consider. Now let's move on to the eighth question. The depth of tension crack for a backfill having loaded by an uniform surcharge Q. So there exists some surcharge of Q value. So if there is some surcharge, then what will be the depth of tension crack? Consider the backfill is a cohesive soil with a cohesion value C. So what will be the relation for depth of tension crack in case there is a uniform surcharge? So option A, ZC equal to 2C root Ka minus Ka into Q divided by Ka into gamma. So in case there is no surcharge, we have already seen the ZC formula. That is nothing but ZC equal to 2C by gamma root Ka. But here a uniform surcharge is existing. So in this case, ZC value will be given by using this relation, is that is 2C root Ka minus Ka Q divided by Ka gamma. Simple. If there is no surcharge, that is Q is 0, then 2C root Ka by Ka into gamma. So root Ka by root Ka is nothing but 1 by root Ka. So we can find 2C by gamma root Ka. Simple, yes. And let's move on to some other points regarding this tension crack. There will be no tension cracks in passive earth pressure case. This point we have already dealt in the previous question. Only in active earth pressure case there exists tension crack. There exists unsupported vertical cut. But in case of passive earth pressure, that is wall moving towards the backfill, there is no debate on tension crack formation and no condition like unsupported vertical cut, because the wall is moving towards the backfill. And before tension crack formation, now coming to active earth pressure concept, and before tension crack formation, what will be the total thrust that is given by Pa? So this is the basic formula. In case there is no stratification in the soil, only cohesion soil the throughout the backfill, only one cohesive soil is existing. And for that condition, before tension crack formation, what will be the total active pressure thrust? So that is given by this relation. Pa is equal to Ka gamma z square by 2 minus 2z gamma root Ka, sorry, 2c root Ka into z. No gamma here. 2c root Ka into z. And this will be acting at uh, this from base, that is Ka gamma h minus 6c root Ka by Ka gamma h minus 4c root Ka into z by 3. This value can be found by using earth pressure distribution diagram, or if we can memorize this relation, that will help us to get the answer in a quick and short way without drawing the earth pressure distribution diagram. And this formula will be applicable only in case the backfill is uniform. That I mean, only one backfill is there. There is no stratification. And before tension cracks, this will be the relation, and at this depth, this Pa value will be acting. And this is the diagram for, this is the representation for before tension crack formation, how the earth pressure will be varying. Here minus 20 Ka, and here the root Ka, and this depth is the unsupported vertical height, that is 2 into ZC or Z naught anything, and the net pressure will be Ka gamma H minus 2C root Ka. And this is the pressure and this is the thrust value, that is the force per unit meter run, that is Ka gamma Z square by 2 minus 2C root Ka Z. And in case of tension crack is formed, that is here you can see tension crack is already formed, that means the Z0 layer is failed, so there is no there is no support for the Z0 layer. So from after the Z0 layer, we have to calculate the earth pressure. So Pa is equal to Ka gamma Z square minus 2C root Ka Z is the condition, and plus 2C square by gamma. This term has to be added in case of after tension crack formation. And this will be acting at Z minus Zc by 3 from the base, that is this distance. This distance is nothing but Z minus Zc by 3 from base in case the tension crack is already formed. So these are some basic things regarding tension crack formation and what is the relevant formula and how to use in case of surcharge is given, and what will be the formula in case of after tension crack and before tension crack. And tension crack concept is applicable only for active earth pressure case, and there will be no tension cracks, no vertical unsupported cut in case of passive earth pressure case. And we shall move on to the next question. If water table is found at certain depth in a backfill, then the earth pressure has to be. Here they have mentioned as the earth pressure is calculated with the effective stress, that is sigma bar, that is K into sigma bar is the earth pressure that is already found. And after that, after finding that value, what has to be done in case of water table is present, that is asked. So here the option A is correct one. We have to add that water pressure for that certain depth or the depth of water which is occurring. Let's see in this diagram so that we can clear what is mentioning here. Here you can see the water table is lying at some h1 depth from the top, or the water table is at h2 meters. What we have to do is first we are calculating the PP value or the PA value, that is in case of active earth pressure we find PA value for various depths. After finding that PA value has to be added with gamma W into H, where this H is nothing but H2 in this case. In this diagram the water table is around H2 distance or H2 depth, so that value has to be added because this water will also giving active thrust, so that's why we are adding after calculating effective stress, that should be multiplied by coefficient of earth pressure value. After getting all those things we have to add this plus gamma WH. After calculating the effective stress at various depths, the earth pressure has to be added with water pressure, that is nothing but plus gamma WH. Now we shall move on to the next question. So before moving to that, we shall see in this diagram also. Here you can see gamma WH2. So up to this point, the active earth pressure is calculated, that is PA value, and after that gamma WH2 has to be added. So this is the basic concept here, or the thing behind it. In case water table is present, we should not leave the water table as is, because we have already found already found the effective stress. That is not the thing. If even after finding the effective stress and multiplying that with the coefficient of earth pressure, we have to add the gamma WH in case of water table is present. So this is the main thing we have to be aware of. Now let's move on to the 10th question, last one. Active earth pressure will be developed in backfill when? When will the active earth pressure will develop? When there is horizontal strain 0.5%, or when horizontal strain is 1%, mobilized shearing resistance along the failure plane is maximum, or when it is minimum. which will be applicable for an active earth pressure. So option A and C, that is, for an active earth pressure, horizontal strain will be around 0.5%, that is very less. And in case of active earth pressure, mobilized shearing resistance along the failure plane will be maximum, as we can see in this diagram. The mobilized shearing resistance will be more in case of active earth pressure. It will be less in case of passive earth pressure. And for active state, the horizontal strain is 0.2% in case of dense soils and 0.5% in case of loose soils. So uh, we can infer like this: the horizontal strain will be less for active state and it will be more for passive state. Here you can see horizontal strain for passive state in case of dense soil is 2%, in case of loose sand is 15%. The width of sliding wedge is hatch cot of 45 plus pi by 2. That is nothing but this one. This is the width of sliding wedge, and what is the value of that? Hatch into cot of 45 plus pi by 2. This is the hatch value, that is total depth of backfill, and into cot of 45 plus pi by 2 gives the sliding width of sliding wedge in case of active state, and in case of passive state that will be 45 minus pi by 2. In case of passive state, it will be 45 minus pi by 2. So these are some more points regarding active earth pressure and passive earth pressure. So we have learned almost all the concepts, all the formulas, very important things like unsupported vertical height, depth of tension crack in case of active earth pressure, how uh, earth pressure has to be calculated, what is thrust, and the point of acting of the thrust value. All the things we have dealt. So I hope it will be useful to you. Thank you for watching. Please subscribe the channel and share with your friends. And you can post your comments and suggestions right now. Thank you.